Looking at more similarity criteria, we actually know the definition of similarity, which means all corresponding angles are congruent and all corresponding sides are proportional. That means if you divide matching sides, you should get the same number for all three sides. But we're going to look at some more shortcuts. We also looked at angle similarity. And I'll just do a picture for this. Angle similarity. For angle similarity, if you have two triangles, then I'm just going to sketch really quick. So if you have two triangles with two angles congruent, then automatically the triangles are similar. So if you have two angles on one triangle congruent to two angles on another triangle, then automatically the triangles are similar. I'm going to box this off. So that's a little bit of a shortcut. We don't have to check all the angles, and we don't have to check all the corresponding sides for proportionality. We can, if we have two angles congruent, we can just say automatically the triangles are similar. And then if we wanted to write the similarity statement, we'd have to match up the angles. So that's just a little bit of a review. The new ones that we're going to look at, which I didn't realize were involved in the other assignment, are side similarity. And again, that's SSS. And that's just saying if all three corresponding sides of two triangles, if they're proportional, then you can jump right away and say that the triangles are similar. So you don't have to find that the sides are proportional and then find that the angles are congruent and then say that they're similar. You just need all the sides proportional. So I'm just going to say if all corresponding sides, if all corresponding sides of two triangles are proportional, meaning when you divide them you get the same number, proportional, then the two triangles are similar. So we don't have to do anything extra after that. And that's side similarity. And then the last one before we get to the examples is similar to the ones that we had before, but it's going to be side angle side similarity. Notice that I'm not talking about congruence in these cases. When I'm describing, I'm using the word proportional. That's important because I'm not checking to see if they're congruent for the sides. I'm checking to see if you divide them in the correct order, do they give you all the same number? That's what I mean by proportional. With angle, those angles would be congruent. But with like the sides, we're talking about proportional when you're trying to prove similarity. So side angle side similarity. If you have two sides of two triangles proportional. So if you have two sides of two triangles proportional, and the angles in between are congruent, then the triangles are similar. And we'll definitely see what this means once we get to our examples. But if you have two sides of two triangles proportional and the angles in between are congruent, then the two triangles are similar. You must have the angles in between. The angles that are congruent have to be in between the two sides that are proportional. Okay, so the first thing that we're going to be looking at is number 1. And it says, state if the triangles in each pair are similar. If so, state how you know they are similar. And then write the similarity statement. Remember, this little symbol means similar. So, on this, the first thing that I recognize is that these two angles are vertical angles. So I know they're congruent by the vertical angles theorem. So those are congruent. That's great. Now I'm going to attempt, because look, I have a side, then the angle, and then a side. I'm going to try and use side, angle, side criteria. And that says, well, I have the angle in between congruent, so that's good. Now I'm going to compare corresponding sides and see if they give me the same ratio. So I think what I'm going to do is compare SU to DU. Already you might be able to tell that this is not, they're not similar.
Yeah, no, because one side's 40.
Yeah, these are 16 and 16.
But that's 30.
These are 39 and 40. If they were similar, these would also be the same number as each other.
Then you would do the math.
Yeah. I'm just going to continue showing this. 39 divided by 16. I'm just going to show that these aren't right. 39 divided by 16 is like 2.4375. And then the other one won't be the same thing. So TU divided by UE. Oh, way. 40 divided by 16. That would be 2.5. So these are not similar because those sides were not proportional. Something that I want to point out, when I am comparing, I did SU divided by DU. That was the bigger triangle on top and then the smaller triangle on the bottom. When I do for all of my fractions, it has to be in that order. Big triangle on top, TU, small triangle on bottom. I have to keep the order consistent. So this first one is no, they're not similar. The second one, on this, number 2, well, I don't have any angles congruent, so I'm not going to use side angle side or angle angle. But I'm going to compare.
Yeah, can't you just like 40 divided by 8?
Yeah.
And then do like 84 divided by 40?
Exactly. We're going to do, and this is the way that I match it up. If I'm going to go, I'm going to go from the big triangle to the small triangle. And I'm going to look, okay, what is my smallest side? That would be CB, right? So to figure out what corresponds with CB, well, this was the smallest number out of the 3, so I have to compare it to the smallest number out of the 3. That would be compared with GF. And CB, 48 divided by 8, that's just 6. You have to make sure that you're comparing the correct side, the smallest side with the smallest side, in the correct order. So I chose to do big triangle to small triangle, big triangle on top, small triangle on top. All my other fractions have to be that way. The next biggest number, actually, let's ask some questions here. So AC from the big triangle, that's the largest side out of the 3. So then I have to do HF from the smaller triangle because that's also the largest side there. I have to compare that correctly, and I also have to ACHF, do it from big triangle, small triangle, because that's what I did here. So the last one that corresponds is AB. That's the middle number, and this should also be the middle number, and it is. So AB compared to HG, and we get 6 each time, which means all the sides are proportional. We don't have to check anything else. So this is by side, side, side. And CBA, now we have to match up the angles. C matches with F, thank you. B matches with G. And A matches with H. So you have to compare everything in the correct order and then write the similarity statement in the correct order. The question was, okay, all 3 of these came out to be the same number. That's how we know all the sides are proportional. If one of them was wrong, like one of them was not the same as the other 2, then we would not be able to say this, and we'd say, no, it's not similar. The thing to make sure you're doing is, if you're comparing big on top, small on bottom, it should be big on top, small on bottom, big on top, small on bottom, for all of the ratios. If you mess up that other one, it's going to change the number, but you have to do either like big to small in all 3 or small to big in all 3.